Hello. We're together again with one perfect Olympic question. The question is over 81 for us. Sin squared x plus 81 to the cosine squared x is equal to 30. Wants us to find x values. This transformation came to my mind immediately. Sin squared x plus cosine squared x is equal to 1. Where we see sine squared x here, we can write 1 minus cosine squared x. Let's start applying this in our equation right away. 1 to the 1 minus cosine squared x plus 81 over cosine squared is equal to 30. I can separate the tops later on in this part. Above 81, 1 times 81 to the minus cosine squared x plus 81 over cosine squared x is equal to 30. We can immediately think of this where we call a to the minus 1 is equal to 1a. Let's apply this immediately in our equation. 1 times 1 over 81 over cosine squared x plus 81 over cosine squared x is equal to 30. Now let's do a variable change here. So, changing the names of the friends given here, it will be better for us. So we put the question into algebraic form 1. 81 over cosine squared x. Let's call the algebraic expression m. Let's use this 81 times 1m plus m is equal to 30. Right here we can multiply both sides by my. What will happen in this case? 81 plus m squared equals 30m. Let's arrange a little more. We can collect them all on the left. Squared minus 30 times m plus 81 is equal to 0. Now this, I think what can I do after this situation? What did he give us? He gave one equation from the second degree. What should I do? What did we know about it? I know that the sum of 81 times is minus 30. Think about what these numbers are. Let's write m now. What can be minus 27 and minus 3 will satisfy this equation. Then we can express it like this. m minus 27 times m minus 3 is equal to 0. One value we call m from here will come 27. From here the value we call m will come to 3. Now that I have expressed my question in this way, it was better. What was the expression we called m? Let's remember right here. Look, it's written over 81. Above 81. Yes, cosine squared x. And equal 27 came. 1 and 81 over cosine squared x. What happened? 3 has arrived. Of course, what's wrong here? There is a secret 1. I immediately think what power of 81 3. A1 is equal to 3 to the 4th. Cosine squared x force is equal. I think 27 is the power of 3. 3 to the 3, of course. What can I do here? So I can write it like this. 3 to the 4th times cosine squared x is equal to 3 to the 3rd. Now the soles, what will happen at the top in the same expressions, will be equal to each other. I think about it right away. 4 times cosine squared x is equal to 3. Cosine squared x dividing both sides by 4. Cosine squared x, what happened? 4 has arrived. Of course, what do we have to do to get rid of the square? We need to take the square root of both sides. In this case, we call cosine x. 3 in the root, divided by the root 4 will come. Well, of course, there should be a plus and minus in front of you again. Here is the expression we call cosine x. Plus minus root 3 divided by 2 has arrived. Let's look at the other one. What did he say to us in the other? Here, I approach with the same logic again. 3 over 4. I said cosine squared x is equal to the force. 3 to the 1. 3 to the 4th times cosine squared x is equal to 3 to the 4th. Expressions with the same bases. The tops will be equal to each other. 4 cosine squared x is equal to 1. Here I divide both sides into 4. Cosine squared x is equal to 1 4. Let's take the square root of both sides to get rid of the square. In this case, we call cosine x plus minus 1 over root 4. What will this do? Cosine of x is equal to plus minus 1 times 2. Now we have found two values here. Of course, let's draw a right triangle before proceeding to this. Right from the right triangle. How are trigonometric angles? Let's think about how many degrees. Of course we remember them. What were they? One is 30 degrees. This is 60 degrees. Degrees here. I can write root 3 here, 1 here, 2 here. If we want to write some things right here, for example, what is the value we call cosine 30? Adjacent edge over hypotenuse. When we say root 3 divided by 2, we'll take the value. What will be the value we call cosine 60 when we look at it? 1 plus 2 has arrived. Now it means one of our angles. I'd say that's 30 degrees. I can say that this one is 60 degrees. Of course, I just can't get the solution from these angles. Then I can write the expression I call x. X is equal to 30 degrees. Plus k pi, what will be the values we call k here? Will be an integer. But it's not enough. Why would you say this is just root 3 divided by 2 is positive? Applies to situations where, then let's write 1 on this and get x2 minus 30 degrees plus k pi if I say. Again, k here element integer. If we want to show these angles in the unit circle, one of the angles happened somewhere here. One of them happened here. Now someone is 30, what will happen? It's like it's going to be 150 degrees. What will it get as you increase these pi k's? We will get other angles. Now if we want to solve the other, what happened? It came 1, 2, 2. What am I doing right now? We agreed that it was 60 degrees. Let's say x is equal to 60 plus k pi. We can say that k is an integer here again, and what will be the other? I could say x is equal to minus 60 plus k pi. Again k here. I can say that there is one integer. If we want to draw this solution on the unit circle, so what will come? 60 degrees here somewhere. What comes when we add example to the other? When we add 180 degrees, 120 degrees will come. He was in a place like this, and we got this show. So in this case, what were my answers? x1, x2 I already wrote here. Then x2. Sorry, this is x3, this will be x4. Again. In fact, if we want to write more regularly, so x1, comma 2, I can write like this plus minus 30 degrees. Plus kp here, k element integer. If I want to write the other x3.4. So if I want to get from here plus minus 60 degrees, plus kp, I can express k element as an integer here. So, back to us perfectly beautiful one. Math Olympic question. What did we do? Our aim is to reduce it here. So we made the top expressions here as multipliers, and here we come across the second order equation. We found the roots of it. Asked from above equations here, we went to the solution. Thank you for watching me. Please don't forget to follow my channel. Don't forget to like the video. Please see you. Bye-bye.